Salutations, mini mathematicians! So happy you could join us. We're working on 6.1D, approximating irrational numbers on the real number line, and it's a PDF printout. So our purpose today is to be able to approximate irrational numbers to a determined place value, so tenths, hundredths, thousandths, 10,000ths, and use that value in calculations and or comparisons. Quick note, you will not be allowed to use that square root button. So if I'm approximating the square root, so second x squared square root of 35, you can't just put it into your calculator. We're doing this by hand. So if you are tempted, you can always grab just a basic calculator. We will be squaring items. So if you have a basic calculator and you needed to square something, like we were squaring 3.1, I just put 3.1 times 3.1 to get what it is squared. Okay, so let's get started. Pretty exciting. Okay, so again, no radical square root button allowed today, except later when I'm going to let you check your answer and then just keep it on the DL. Okay, so taking a look. How can you determine a good approximation for the numerical value of an irrational number? So we've already looked at irrational numbers as being non-repeating, non-terminating decimals, such like pi. But they are real numbers, so we know we can put them on a number line. So the number square root of 30 is an irrational number because it's the square root of a non-perfect square. So we're going to use the square root of 30 to complete the following. So the first thing we're going to look at is what two integers does the square root of 30 lie? Which integer is it closest to? We might be like, oh no, right? Like square root some number times itself is 30. Well, you know a lot more than you think you know. So first of all, I want you to remember that square roots and squaring are inverse operations. And you're like, I know that, Mrs. Barr, you've told me a million times already. Well, I'm going to tell you a million and one times. Square roots and square rooting are inverse operations. So if I want to know what two integers where square root of 30 is between, you can think about 30 is in between which two perfect squares. It's in between 25, which is 5 squared, and 36, which is 6 squared. So that means what we can do is we can say the square root of 30 is in between the square root of 25 and the square root of 36. Hence, we can say that the square root of 30 is in between 5 and in between 6. So which two integers is square root of 30 in between? 5 and 6. Which one is it closer to? So that's where you go back over here. Well, to go from 30 to 36, I have to add 6. But from 25 to 30, I only have to add 5. So it's square root of 30 is closer to the square root of 25, since 25 is closer to 30 than 30 is to 36, which tells you it's closer to 5. So square root of 30 is between 5 and 6, but closer to 6. So what we have here is we have a lower bound and upper bound. Notice we have the less than symbol, our squishy L, right? Squishy L to show that. And to figure out which one's closer to, I'm always going to give that one a little flare, some circles. So part A says, show its approximate location on the number line below and scale the number line. Well, notice this goes from 0 to 10, and we're talking about integers. So this is going to go 0. What do you think the next number is? You're right, 1, 2, 3. Keep going, 4, 5, 6, 7, 8, 9, and 10. Did you beat me? Are you done already? Perfect. So like we said, square root of 30, we can think about, since square rooting and squaring are inverse operations, this is the square root of 25, and this is the square root of 36, and square root of 30 is in between, but a little closer to 5. So I'm going to plot it and label it as the square root of 30. Yes. Okay. Well, let's zoom in. Oh my gosh, it's just a paper. I can't zoom in. Have you ever tried to zoom in on a piece of paper because you're like, it's like a screen, but I can't. So what we're going to have to do is make a new number line. So we're going to find square root of 30 accurate to 1 decimal place. Remember, that's the tenths place. We're going to show its approximate location on the number line below, and we need to scale the number line. So scaling the number line, if we're going from the tenths, we know this is between 5 and 6. So when we scale this number line, we're going to be going between 5.0 and 6.0. So as we label in between, it goes 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8. You probably finished already. 5.9, because I had to say all of them. Okay, great job. So from here, just like we did above, we can square these numbers and put them under square roots to find which one is closest to radical 30. So taking a look here, since I know square root of 30 is closer to 5, I'm going to start squaring numbers on this side first. You can grab your calculator to square. So I know maybe jump over to like, I don't know, let's try 5.2 first. So 5.2 squared gets me 27. So square root of 27.04. Okay, well, I need to get all the way to 30, so let's try something a little bit more. So let's try 5.6. So 5.6 squared. Ooh, a square root of 31.36. So 5.6 is too big still, because remember, we want a number that's slightly smaller than square root 30 and then one that's slightly bigger, so it's in between it. So let's try 5.5. So 5.5 getting squared. Ooh, I like this. Okay, 30.25. And we'll see if 5.4. Ooh, nice. This is 29.16, all square rooted. So we know that the square root of 30 is in between these two numbers. So to the tenths place, 5.4 is less than square root 30, which is less than 5.5. It's in between both of these, and we want to think about which one is it closer to. So thinking about 30, this is, you can think about like money if you want to do, this is 25 cents more than 30. And this is, if you had a dollar, like it's more than 80 cents less. So this, it's closer to 5.5. So I'm just going to take the 5.5 and give it like a circle or something just to communicate that it's closer to 5.5. Okay, so now we know that square root of 30 is like 5.4 something, something, something. Okay, well, let's do this one more time. Let's zoom in on our number line in between. Oh, you guys, I forgot to plot it. Oh my gosh. I still need to show. So between 5.4 and 5.5, but a little bit closer to 5.5. There's the square root of 30. Nice. Okay, now we can zoom in and go to the 2 decimal places, which we know is the hundredths. Hundred. So 2 decimal places. So again, we're going between 5.4 and 5.5, but now it's the hundredths, so you can think about as 5.40 and 5.50. And sometimes thinking about money in the hundredths is helpful. So 5.41, let's see who can finish. And if you pause me, that's cheating. Boom. Okay. Perfect. So again, we are going to do the same thing. We want to know square root of 30 is in between which two numbers. Since we know square root of 30 is closer to 5.5, maybe I'll start over on this side to square these numbers. So grab your calculator. And again, you're either using a square button or multiplying it twice, and you will need a calculator for the next one, which you're going to do on your own. So let's start with, let's start with 5.49. So 5.49 squared. Okay, this is pretty close. 30.1401. You might be like, Ms. Spar, how do you know what number to go to? I don't know. I'm going to put a couple because what if they're super close together, right? 5.48 squared. I'm hoping this is a number that's less than 30, so I got it. Oh, just, okay, so almost though. So square root 30.0304. So let's try 7. And if you're wondering what I'm doing with these up and down arrows, so you can go up and then just insert replace a number, and it kind of helps you that from having to input the number again. Oh, nice. This is excellent, 29.9209. So we know that square root of 30 is in between 5.47 and 5.48, 5 and 47 hundredths, and 5 and 48 hundredths, because square root of 30 is in between square root of 29.9 and square root of 30.03. Okay, which one is it slightly closer to? Well, thinking about this like money, if it's 2 decimal places, this is 3 cents more, but this is 8 cents less. So we know that it's slightly closer to 5.48. Square root of 30, and I remembered to graph it this time. High five myself. Yes, it's just a clap, I know, but it's a high five. Okay. So what can we do? Well, we can continue zooming in on the location of square root 30, radical 30 on the number line, and location becomes more and more accurate and more exact each time by a factor of 10 because we're in the decimal system, which is base 10. And obviously it gets more accurate. So what we're going to do is we're going to use our numbers from above to add, subtract, multiply, and divide. So we're going to use our work from above to approximate the value of each expression using integers and tenths. So 2 plus square root 30. So what we are looking at is we are looking at 2 plus square root 30, and we're going to give a lower bound approximation and an upper bound approximation. So 2 plus the lower bound approximation for square root 30 was 5. So 2 plus 5. And 2 plus the upper bound for square root 30 was 6. So 2 plus 6. So we know 5 plus 2, it's 7. 7 is less than 2 square root 30. 2 plus square root 30. Sorry, 2 square root 30 would be multiplying. This is addition. Addition and multiplying are very different, but it's less than 8. So 7 is less than 2 plus square root 30, which is less than 8. So it's 7 point something, 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 something. Well, let's find out what that first something is. We can approximate this to the nearest tenths using our tenths value. So remember, this is going to be a lower bound and upper bound approximation of 2 plus radical 30. So 2 plus to the tenths, our lower bound approximation was, that's right, 5.4. And 2 plus our higher bound, upper bound approximation was 5.5. So 2 plus square root 30 is greater than 7.4 and less than 7.5. So we know 2 plus square root 30 is 7.4 something, something, something. Well, this is when I'm going to let you use the square root button. We're using it for good, not evil. We're using it for good. So here, 2 plus second radical 30, close your parentheses, equals, it is. It's about, so we can always write calculator. We get about 7.477. So that is excellent. You guys, we can do stuff the calculator can do. Cool. Okay, so let's try another one. Here we are multiplying 3 square root 30. So with integers, very similar, 3 square root 30, we're going to come up with a lower bound and an upper bound. Remember, integers are positive and negative counting numbers, like we've been exploring this module. So our lower bound for square root 30 is 5, and our upper bound for square root 30 is 6. So we know that 3 times square root 30 is between 15 and 18. Excellent, excellent. Really good job. And then to the tenths, we know that 3 square root 30 is less than 3 times 5.4. Sorry, it's greater than 3 times 5.4, but it's less than 3 times 5.5. So we know that 3 square root 30 is in between 16 and 2 tenths and 16 and 5 tenths. So it might be 16.2 something, could be 16.3 something, 16.4 something. We're not exactly as accurate with multiplying here. And of course, we can check with a calculator. And I do want you practicing putting these in a calculator so you know how to do that. So this is going to be 3 times, and then parentheses, square root 30. I don't think I needed to put those parentheses there, but it's okay. So we get about 16.431, and I'll just put some dots. So that's great because our lower bound and upper bounds match our answer that the calculator gave. Fabulous. So what we're going to do is our next page, you're doing the same thing, but now with square root of 52. So keep this page handy and work through it. And then you're going to also finish for part A and B. Notice this is integers and we're subtracting here. So think about what your lower bound and upper bound is. And over here, notice these are integers. So if you are getting a decimal for some reason, think about what that means for integers. And the same thing here for tenths. Make sure you are giving an approximate value in those place values. Awesome. Go ahead and pause the video and finish this page. Okay, let's go. Let's see how you did. Okay, what two integers is square root 52 between? Square root of 52 is in between 7 and 8, so we placed it on our number line like so. Then to the nearest tenth is between 7.2 and 7.3, but closer to 7.2 because we notice that 7.2 squared is 51.84, which 52 is closer to than 53.2929. Okay. Then to go to the hundredths, we know square root of 52 is greater than 7.21, but less than 7.22. But it's a little closer to 7.21. So we showed that when we placed it approximately on our number line, which we can do because all irrational numbers are still real. Taking a look. Notice, think about which is less because we are subtracting. So here we had to like switch because if we're taking away a bigger number, it becomes less than. If we take away a smaller number, it's greater than. So -5 is less than 3 minus square root 52, which is less than -4. So if you swapped those, just switch swap them again. Get the right answer on there. And to the tenths, we end up with -4.3 is less than 3 minus square root of 52, which is less than -4.2. With our calculator, if you put it in there, you should get -4.211, which we feel really good about. Okay, so from over here with integers, square root of 52 divided by 2. Notice this is square root of 52 divided by 2. It's not square root of 52 divided by the square root of 2, which would look different if that radical symbol went down the entire thing, like if it was 52 over 2 or 52 square root 52 over square root 2, root 52 over root 2. These are equal, but that does not equal what we are looking at, which is square root of 52 all divided by 2. So from here, this is between 7 divided by 2 and 8 divided by 2. So it's between 3.5 and 4, but remember this is integers and 3.5 is not an integer, it's rational. It's a terminating decimal. So this is 3 is less than root 52 over 2, which is less than 4. A little bit of tongue twister, root 52 over 2. And then in the tenths, when we put in those values, notice our upper bound is not in the tenths, so we need to take a look between 3.6 and 3.7. I know if we truncated, which is another type of rounding, we get 3.6, but you can't be between 3.6 and 3.6. So we used our traditional rounding, which we rounded up for the tenths place. We're here, We can't put between 4 and 4. So this is called truncating rounding, where we just cut off, like if we cut a tree at its trunk, we just cut it off without changing any of the numbers. Okay. And if I check with my calculator, it's about 3.605, which is excellent. Okay. So last page. So it says, without using the square root button on your calculator, order the following numbers from least to greatest. So least to greatest, and no square root button, no radical. Don't touch that. Okay. So here, when we are going to list them, the first thing I'm going to do is I'm going to either write all of them as squares or all of them as square roots. It looks a lot simpler here to write them all as square roots. So I'm going to write this as square root 80, 8 squared square rooted, because squaring and square roots are inverse operations. We have square root of 64. 9 is the square root of 81. And oh no, 8.5, you guys, how are we going to do this if we're not using a calculator? Check out the note. Oh, so nice. Square root of 72.25. Might need to extend that radical a little bit. And then we have square root of 62. So from here, it's way more efficient to order them from least to greatest. So the least is square root of 62. And sometimes I like either crossing them off or putting a check after I already use them. So 62, 64, square root 64. The 70, so square root 72.25. And then square root 80. And then square root of 81. But we are ordering the following numbers. So we need to rewrite back into the original form that our numbers were given them. So square root of 62, that was already the square root of 62. Okay, and then square root of 64, well, that was given to us as an 8. Square root of 72.25, well, that was given to us as 8.5. Square root of 80, that was given to us as square root of 80, and square root of 81 was given to us as 9. So this is our answer, and always double check your reasonableness. If for some reason your 8.5 came before your 8, that is not from least to greatest, right? So always maybe double check least to greatest. Oftentimes the biggest mistake is listing them from greatest to least. And so always double check after you list them if you went in the correct direction. Okay, why don't we pause and you finish 6 and 7, and we'll go over them as soon as you're ready. Okay, let's go over 6 and 7. So number 6 here, be really careful with the negatives, you guys, because notice least to greatest, the greatest numbers are going to be closer to 0 to the right. So it's going to seem like it's switch swap because it's negative. Also remember, we cannot take the square root of a negative. It's imaginary. So from here, we always have these negatives on the outside of the square roots. Cannot put a negative inside a square root. Okay, so we rewrote them, we ordered them, and we wrote them back into their original. So -4, negative square root 13, negative 3.5, negative 3. Check for reasonableness. It's looking good. Let's keep going. Number 7, pretty straightforward. Rewrote them all under square roots, ordered those square roots, rewrote them back into the original, and we're good. So notice number 8, we are using the same numbers from number 7, and the same thing with number 9. So let's take a look at number 8. So we want a rational number that's smaller than all those numbers. And again, notice these are the same numbers from number 7. So 6 is the smallest. So answers will vary here, but it needs to be a rational number. It needs to be a rational number. So answers will vary. And you can think of, if you wanted to, that square root of 36 is 6. That's not going to help you out too much here, because remember, rational numbers are square roots of perfect squares. So we could say, if it's less than that, we could say square root of 25, square root of 16, square root of 9, square root of 4, square root of 1. Another rational number, we could use 1/2. We can use 5/2. We can use 5.283. We can use -6.85. Options are endless, but make sure it's a rational number that is less than 6. Perfect. Why don't you finish 9 and 10, and we'll go over those answers as soon as you're ready. Okay, let's take a look at 9 and 10. So number 9, notice you wanted an irrational, non-negative, which means positive, number that's smaller than all these numbers. Notice this is also the same as 7, so we need to be smaller than 6, and your answers will vary. Because this is irrational, and we've talked about an irrational number is the square root of a non-perfect square. We can use the square root of numbers that are less than 36 but are not perfect squares. So square root of 2, 3, 5. Why did you skip 4? Oh, 4 is a perfect square. It would be rational, not irrational. Perfect. So again, answers will vary here. No terminating decimals, no repeating decimals, no fractions. Cool. And then find a number between square root of 42 and 6.5. Maybe you were like, oh no, 6.5. Then you're like, oh yeah, our note up here on number 7 gave us 6.5 squared. So this needs between the square root of 42 and the square root of 42.25. If it helps you to think about it as the square root of, oops, I don't know why I can't write there, 42.00 and 42.25, that can help you also. So 42.1, so square root of 42.1, square root of 42.2, square root of 42.24, square root of 42.23. All of those are going to be numbers that are in between the square root of 42 and 6.5. I caution you against thinking 6.4, 6.41, just because we're not exactly sure unless you have a calculator. So if you did look at 6.4 squared, notice that's 40.96, which is not between 42 and 42.25. So we do want to stick with numbers that are going to be under our radicals because we are more confident and sure about that. Excellent job, mini mathematicians. Great work approximating irrational numbers on a number line and then using those values to compare and do calculations. Learning something new, the more you know. Thanks. Do your best. Be nice to everyone, and I will see you next time.